Hi there, and welcome to episode Suite 16 in our virtual classroom series for Oracle database upgrades and migrations. The title of this episode is Release Strategy and Patching. And if that sounds a little familiar to you, it's because it's also the same as the first episode in the series. And no, this is not one of those reboots of a streaming series. This is an update to the release and patching strategy for Oracle database. Some of the things that might have changed since we released 19C, and some of the things that will be new for Oracle Database 23C. You see, this is the perfect time to start talking about 23C because Oracle Database 23C Free is available for download right now, and we're in the middle of Beta 2 towards the eventual production release. My name is Roy Swanger, and I'm Vice President for Oracle Database Patching, Upgrade, and Utilities here at Oracle. And doing most of the heavy lifting today will be the other folks that are here with me. Mike Dietrich, who you know as the worldwide expert on Oracle database upgrades and migrations. Daniel Overby Hansen in Denmark, also very skilled at migrations, especially cloud. And you might have seen his recent blog posts about patching in Oracle database or grid infrastructure. And finally, from Brazil, Rodrigo Jorge, who has a lot of experience in mission critical and MAA environments such as RAC and DataGuard. You can get all the slides as usual from the Upgrade blog at mikedietrichde.com/slides. They will be posted by the time you see this video. And remember that this is, after all, number 16 in our video series. There are a lot of different topics that we cover in great depth. Of course, many of these are also available in our YouTube channel. We'll talk about that at the end of this, but you can pick and choose the segments that you want to see on demand for free at any time. So without further ado, let's get into this episode, the release and patching strategy for Oracle Database, specifically towards 23C, and I'm going to hand it over to Daniel to get us started.
Thank you, Roy. You are absolutely right. Let's get started. We have so many interesting things to talk about today, so let's kick it off talking about release strategy. This is an overview of the current releases of Oracle Database. I think it goes without saying that Oracle Database 19C is the release that you want to be on right now. It is the release currently with the longest support period. Some of the older releases are still supported. They are under market-driven support. But if you are running one of those older databases, you really need to upgrade to 19C as soon as possible. Talking about 19C, good news. We recently announced that the first year of extended support has been waived. So you don't need to pay additional support fees once we entered extended support for Oracle Database 19C. This should allow you some more time to upgrade to the next release. Talking about the next release, it is time to make your plans for the future. The next release of the world's best database is Oracle Database 23C. And I'm sorry, I cannot share the release date with you here today, but you should know, behind the scenes, our developers are working really hard to tie up the final loose ends so we can produce a really good release for you. It'll be 23C, and it is our next long-term support release. So a release that will offer a longer support period. Because we have two kinds of releases. We have a long-term support release where we offer at least 5 years of premier support, followed by 3 years of extended support. And in contrast to that, we have the innovation releases, which has a much smaller support period. For your production databases, you should stick with long-term support releases. We recommend that your production database move from one long-term support release to the next. The innovation releases in between are really not fit for a production database due to the short support period. But if your business can really benefit from one of the new features in an innovation release, you can safely upgrade your production database to an innovation release. Just be aware that you need to plan the next upgrade. It's coming pretty soon due to the short support period. The next long-term support release will be Oracle Database 23c, the next release that comes out. When you need to plan your upgrade to 23c, you should know that direct upgrade to that release will only be possible from Oracle Database 19c and 21c. So if you have one of those older databases and you want to upgrade them to 23c, you have to go via Oracle Database 19c. You have to do that as an intermediate upgrade. Because if the aim for those old releases is to go to Oracle Database 23c, then there is no direct upgrade possible. So everyone must upgrade to Oracle Database 19c. Also remember that Oracle Database 19c, it is the last release to support the old non-CDP architecture. So once you want to upgrade beyond 19c, you need to convert into the multi-tenant architecture. So even if you are staying on 19c for a while, get started with the multi-tenant architecture. Take some of the databases in your environment and put them into a container database. In Oracle Database 19c, we allow you to put in 3 of your own PDBs into a container database without having to have the multi-tenant license. If you want to put in more PDBs than 3, then you need the multi-tenant license, obviously. But on 19c, even on Standard Edition 2, we allow you to use the multi-tenant architecture with 3 PDBs. So I really recommend, even if you don't plan on adopting the multi-tenant architecture yet, do still convert a few test or development databases to the new architecture. It allows you to learn something about the new architecture, because whether you like it or not, once you go beyond 19c, you have to convert into the multi-tenant architecture. Now that we talked about release strategies, let's talk a little about patching strategies, and Mike will guide you through it.
Thank you, Daniel. That was a very good introduction. And now let us go to the next topic, installation and patches. So the idea is to highlight what you need, how you start actually, and get a really solid basis before you start upgrading or migrating to the new release. So in this point, let us start with one of the most important slides of our presentation here, the path to a successful database upgrade or migration. And it always starts with not just the base release, but also adding the right patches. So we'll cover this here. And later in this presentation, we'll also talk about where and how and why should you get the most recent AutoUpgrade, especially also in relation to using AutoUpgrade for patching. Today, we won't cover the third and very, very important point of collecting performance information from your source and then making sure you don't hit any unexpected surprises when you upgrade or migrate to the new release. We have 2 virtual classroom seminars covering the entire topic of performance stability, performance tips and tricks. So feel free to access one of those, please. Now, when you start with 19c or later with 23c, it always starts with the base release. The base release is 1930. And it got released in 2019. Now it's a few years later. So you may have this idea of like Oracle fixed a lot of things and better to apply some additional patches before you start really working on testing your upgrades and migrations to that release. But how do you find them? And this is very simple, very straightforward. You start here with the download assistant. This mouse node should be in your favorites list. So you see this in the yellow star in the upper left corner of the slide. And then you click on Oracle Database Updates. This is the release updates. And on the right side, there's a table appearing after you choose 19c. And this gives you access to the database release update, to the Windows bundle patches, and to the grid infrastructure release update as well. So take the newest here, or at least N-1. Just to give you an idea how many fixes are included, you can do the math now and add all these numbers, and you come to a pretty high number, almost in the 5 digits. So approximately 500, 600 patches on average per release update are included and delivered. And you should make sure that you apply them. If you don't do so, you miss thousands of fixes. And very important, not only in these days, but I think we have always to talk about that, you miss the security fixes. And there are more than 240 security fixes in 2019. So you really must make sure that you take the most recent release update. In addition to that, in MOS Node 555.1, the recommended patches, you will find now the things we didn't include in the most recent one. I have here on the example slide, on the screenshot, intentionally 1918. So there are some things which are included in 1919. You see this in the second column here where it says fix in RU 1919, but you see some others are missing as well. Why is that? There could be several reasons. If the column non-rolling says yes, that means we never can include it in a release update because it's not RAC rolling, not standby first. But it could be simply that we learned too late about that issue, and so we had no chance to squeeze it in. Like the top issue from 20th of April, that was fairly after the code freeze for 1919. So it is still mentioned here, and you should be aware of the fixes included here. And this MOS node plays another role. I'll come to this in a minute. And this brings us directly to the monthly recommended patches. So the idea of the monthly recommended patches, which is a fairly new thing, it started with 1917, and right now we offer them only in Oracle Database 19c. This is a collection of several one-off fixes, not too many. When I say several, it means maybe a dozen of fixes, not 500, not 1,000, just a dozen of fixes on top of a release update. So the idea is, you go live now on 20th of April. You decided you do all your testing on 1917 or 1918. And before you go live, you can add a small bundle of very important fixes on top. Without changing anything, no optimizer fixes included there and so on. So this is the idea. And originally, we came in with release update revisions. But the release update revisions had some downsides. So we said, okay, and actually the uptake was very, very little. So we said, look, let's change this for something more practical for customers and something which does not change the release numbering. So let me guide you through the monthly recommended patches. So I told you, we tell you, take the most recent release update or N-1. So for instance, 1919 or 1918. And now when we look closer, we started this with 1917. For a period of 6 months, every month, we release a small amount of fixes on top of a specific release update. And they are not interchangeable. On top of a specific release update. And the idea is, it's a convenience thing. You don't have to. But as a convenience, we offer that you can get the most important fixes on top without downloading fix after fix as a one-off from MOS 555.1 and another node. This is the idea. So it started with 1917. And a month after releasing 1917, in mid-November, we released the first MRP, the first monthly recommended patch. And it included a few fixes. And you see here a snippet of MOS node 555.1. Now, a month later in December, we have learned a bit more. There may be a new issue now in 555.1, and we include that into the MRP too. And so we march forward. Now in January, we released the MRP 3 for 1917, but at the same time now 1918 got released. A month later in February, we released the MRP 1 for 1918 and the fourth MRP for 1917. And another month later, in March, the fifth MRP for 1917 and the second MRP for 1918. Now the turning point will be April, because in April, we not only released 1919 and the third MRP for 1918, we released also the last and final MRP for 1917. So let's assume it's now April the 20th. And you decided, we did our testing. We started in January with 1918. The ideas with the MRP3 available mid of April, you get now maybe a dozen very important fixes on top of 1918 without needing to download them fix plus fix plus fix. This is really the idea of MRPs. We move forward now. So in May, you will see that there's nothing delivered anymore for 1917, but now we deliver an MRP for 1918 and the first MRP for 1919. And this is how we march forward in the future. So we'll always have two MRP streams in parallel for the most current and the previous release update on top. So where's the information coming from? We source the MRPs mostly from 555.1. This is the node which matters, and we try to include those on top, and you see the third column fixed in MRP, where you see that an issue has been fixed in an MRP, and then it's enough to download the MRP instead of the one-off fixes. So an MRP is a collection of several one-off fixes, and it's delivered via merge patch. So this is the idea. It does not change the release number. This is very important. So at least in 19C, no change in the release number. We'll see what happens in the future, but in 19C, there's no change happening. And we think this is very important because then there's no difference to the application. It means it's exactly the same thing as if you would apply a few one-off patches. And again, an MRP is a convenience package. You don't have to. You can also download the one-offs piece by piece if you prefer that. They're cumulative within one line of an RU. That means you saw 6 MRPs on top of 1917. Now you can't take them and put them on 1918. And vice versa. You can't take an MRP from 1918 and put it on top of 1917, because ideally all the things are fixed in the most recent MRP for 1918. They are delivered right now on Linux only. We'll see how the uptake is, and then we may decide at a future stage to deliver them on other platforms as well, but right now, only on Linux. The MRPs contain also security fixes. At the beginning, we said they may contain. Now, I think for 1917, last time I checked, there were 3 or 4 security fixes included, which is actually a very good thing. Yeah? You get an MRP, a dozen of fixes, 4 of them are security fixes. That's actually a very good treat. So really good idea. And soon the MRPs should be available also in the cloud, in OCI, and also on Exadata database clouded customer systems. And then there's a second very, very important node to take care on. And on top, or in addition, not on top, in addition to 555.1, we have this node with the number much harder to remember, actually, 278.16.12.1, or 2, actually. So even it's hard for me to read that from the slide. But what you see here in the different tabs is it combines now special performance fixes, fixes for Golden Gate, Oracle Text, platform-specific fixes. When we say, okay, on this platform, there's a very important platform-specific fix you should apply. Then for HA, DNFS, very important for those of you who use the DNFS. And last tab here, very to the right, data pump. Yes, we deliver special fixes for data pump because normally they are not RAC rolling. And Roy will now tell you way more about the specific data pump fixes. So, Roy, you can take over, please.
Thanks, Mike. You know, I'm really glad you mentioned that patches to consider note, because I wanted to key in on one specific aspect of that note, which is the tab labeled data pump. If you go to the data pump tab in the patches to consider note, it will refer you to the note that you see on this slide here for the data pump bundle patch. Every quarter, we produce a bundle patch for fixes for data pump on top of the release update. And the benefit of that bundle patch, of course, is that you will have fewer known issues that might affect your data pump operations, your imports, your exports, your transportable table space migrations, and so on. But there's another kind of hidden benefit to that patch, and that is that once you install the data pump bundle patch, it'll make all the patching on your database faster going forward. We'll talk about why in a little bit. So this data pump bundle patch for 19.19, which is the most recent release update as of this recording, that one had 125 fixes in it, all tested together, integrated so that you can apply them with confidence. And they're very important fixes, so you might be wondering, well, if they're so important, why aren't they in the release update? The reason for that is simple. Release updates have to be RAC rolling installable. And a lot of the fixes that we have for data pump involve create or replace of a PL SQL package. And the thing about that is, if you're using a PL SQL package, when we try to replace it, we will hang until you're done using it. And in the context of data pump, that means that it could cause Datapatch to hang for minutes or hours until your data pump import or export completed. So we don't want that to happen in your patching windows. So that's why the data pump fixes are separated out into this bundle. But it's not as bad as all that. It's actually a very easy bundle to install, and I'm going to explain why. The reason is that the contents of the data pump bundle patch, while not RAC rolling installable, are what we call a non-binary online installable patch. That means that you can install the data pump bundle patch as long as nobody is using data pump on the system. And that's true of a RAC database or a single instance database. The reason for this is that the contents of the patch are non-binary. That means they're SQL statements, they're PL SQL packages, XSL style sheet changes, but they are not the executable images or the shared libraries that get placed on disk. If we were touching those, then you would have to restart the database, but we're not. It's just SQL operations that will update PL SQL packages and do other things such as view definitions in the database. So this non-binary online patch install is in some ways actually better than a RAC rolling install. It just has that one caveat that you can't have data pump running when you install it. So installing a patch has two parts. First is opatch. Opatch for the data pump bundle patch is pretty simple. It'll run when your database is running, because we're just taking a bunch of wrapped PL SQL packages, those PLB files, or maybe SQL scripts. We're putting them into your Oracle home. Then you run Datapatch, and the key is that you want to run Datapatch to install this bundle when nobody else is using data pump on the system. But how do you know that? There are some views you could query and some ways you could find that out, but we're not going to make you do that. We've already built in safeguards. This has been true of data pump patching since, I think it was 12.2, where we put in this locking mechanism in the dpload.sql script, and that means that one of two things could be the case. Either maybe I try to install the patch while you're running data pump, like an import or export, or maybe I'm installing the patch already when you try to start your data pump job. We take care of both of those eventualities. In this case, what you'll see is if you try to install the data pump bundle patch when someone has an import or export running, you will see this error saying, well, you can't upload or you can't update data pump right now because it's in use. So please try again later. And we also tell you the processes or sessions that are blocking you from installing the patch. So you can go talk to the person who's running the data pump job, find out when it is going to complete, or maybe whether it can be stopped and restarted later. On the flip side, if you're installing the patch and one of the users tries to start a data pump job, they will get an error saying that they can't start the job right now. Now, error before 19.14 was not the easiest thing to understand, but 1914 was 5 release updates ago. It's more than a year ago. Ever since then, we've got a very informative error message that just says data pump software update is in progress, so try again later. Not only that, but the data pump patching with the new DP load infrastructure runs about 90% faster than it used to. So the period of time where you're installing this patch is going to be on the order of 30 to 90 seconds. So we have these patching safeguards that work both ways. Again, if you try to install the patch when someone's running data pump, you will get a message. If someone tries to start a data pump job while you are installing the patch, they will get a message. And we make sure that there's no conflict between it. Makes it very possible to install this on a running production system. Now, I mentioned that once applied that the data pump bundle patch will actually make all of your patching on your system faster. The reason for that is that some of the things we're doing, I mentioned view definitions, for example, is updating queries and view definitions for the things that are used to access various aspects of the data dictionary. And those dictionary views, as they get more performant, are used by other parts of patching as well. So we've seen customers report 20 to 30% speed improvements on their patching. More than that, the other aspect of performance is that a lot of the fixes in the data pump bundle pertain to performance as well. So you'll find that whether you're dealing with lots of partitions or you have a whole bunch of other objects in the database, you might be like this customer from financial services. Unfortunately, we can't name them, but they reported to us that for their application importing, it was a 66% performance improvement because of the number of tables and other objects that they were having to import and the more efficient parallelism that was in place. So going from 2.5 hours to do an import to 48 minutes to do that same import, that's pretty impressive. This is why we want you to install that data pump bundle patch. So that's enough about the data pump bundle patch. Let me turn you over to Rodrigo to talk about how AutoUpgrade makes your life easier with patching.
Thank you, Roy. Now that we talked about release strategy and installation, let's see how we can upgrade and patch our environment. So I believe that at this point, all of you already know about AutpUpgrade, the official tool in Oracle for upgrading databases. But what a few people know is that AutpUpgrade can also be used for patching. Yes, we can use AutpUpgrade for patching as well. And we are going to see how it works in a few slides. And remember, AutpUpgrade also fully automates your migration to the multi-tenant architecture. So if you have your database in the source system as non-CDB, AutpUpgrade also optionally converts to the CDB architecture if you want. And also, AutpUpgrade will handle systems in the source database that have transparent data encryption, TDE enabled. Okay, this works with the new key store functionality that we added in the latest versions of AutpUpgrade. Now let's take a quick look in the AutpUpgrade overview. In AutpUpgrade, first we create a config file where we can specify the source home, the third home, the Oracle seed, and also odd properties if you want to change the AutpUpgrade behavior. Then we run the analyze mode where some presets are going to be executed to see if our source system is ready to be upgraded or to be patched, as we are going to see in a few slides. And finally, we call the AutpUpgrade tool, which optionally can also convert to the PDB architecture. And then we move from a source system that can be 11.204, 12.102, 12.201, 18C, 19C, to a third release, which can be 12.201, 18C, 19C, 21C, and soon 23C. So AutpUpgrade works like a one-button approach. You know when you have your phone and then you get a pop-up saying that you need to upgrade your phone? The idea that we had with AutpUpgrade is to make the upgrade process much easier for the end users, just like a one-button click. And you can officially set some parameters in the config file to change a bit the behavior. One important thing to do before running AutpUpgrade is to check if you're running the latest release of AutpUpgrade. So AutpUpgrade has a different release cycle compared with the quarterly patches that we have, like the RUs, the BIP bundle patches, the OJVM patches, and so forth. So always check if in this Moz node, if there is a newer version of AutpUpgrade before running it. And then compare with the version that you have in your system. How do you do that? You run AutpUpgrade.jar -version, and there you will have a build date and also the target versions that it supports. So compare with the release that we have in Moz and check if you are using the latest one. So now is the surprise. We made upgrade very easy with AutpUpgrade, and now we added also in AutpUpgrade the support for patching. Meaning, for example, you can go from 19.10 to 19.18 using AutpUpgrade. You don't need necessarily to be upgrading to a higher release. You can use AutpUpgrade to move a database from home A to home B that are running in a same release, but with different patch levels applied. How does it work? First, you install a new Oracle home at the same release, and you apply on top of it the newer RU or the RU that you want, and also some additional patches like the data pump bundle patches or the OJVM patches, and also some one-offs that we have in 555.1 Moz node, for example. Then you create a simple config file, as you're gonna see in the next slides, and finally you call AutpUpgrade. So again, AutpUpgrade now supports moving to the same release. It will skip the upgrade step and only run the patching step. So this is an example of a config file. Here we are moving this 19C database from 19.18 database home to a 19.19 database home. After we create this config file, we simply call AutpUpgrade, passing the config file and mode deploy. So it's gonna run all the pre-checks and finally patch our environment, moving this database to this new Oracle home. So why AutpUpgrade with patching is so cool? Because first, we are using the same interface that we used for upgrade. So it's a familiar interface, it's the same console, the same file loading structure. Also, with AutpUpgrade, you also have all the analyze mode phase. So all the pre-checks that we have in AutpUpgrade will be executed against your system to see if everything is okay for moving forward with the patching process. All the protection that we have in AutpUpgrade, you're gonna be using for patching as well, meaning it's gonna be fully resumable. So imagine you have a failure in the middle of the patching process. When you restart the AutpUpgrade process, it will continue from the point where it stopped. And also all the restoration capability, meaning, for example, if you want to go back to the GRP, the guarantee restore point that is created before your patching process started, you can using AutpUpgrade. So you can roll back to the point your database system was before you even started the patching process. And it will roll back and move the database back to the previous Oracle home. And also all the automations we have, for example, for changing the Oracle tab entries pointed to the new Oracle home, also moving the circlenet.aura files, tnsname.aura files, and all the files that we have in Oracle home that needs to be moved to the new Oracle home, all those automation is inside AutpUpgrade. So when you use AutpUpgrade for patching now, you don't need to care about this because AutpUpgrade will handle this for you. So we love AutpUpgrade. And now with the patching capability, you can leverage in all the capabilities we have already in AutpUpgrade, like handling encryption, doing hot clones, refreshable clone. AutpUpgrade fully handles RAC environments. It has the proactive fit subs capability and also the distributed upgrade mode, where it is gonna be using different RAC nodes to speed up your patching process. But right now, AutpUpgrade only supports out-of-place patching, okay? We are putting some enhancements on the tool for the next releases where we are planning to also support in-place patching process and other features. So what we have missing there? First, we don't support Windows, unfortunately. Secondly, RAC Rolling is still not supported. So when you patch using AutpUpgrade, you will have a full outage because we are moving we are stopping the database, moving it to a new Oracle home, patching it and then starting the database. So we have a downtime. We cannot do RAC rolling yet. And also we cannot handle data RAR automatically. You would need to do some steps. If you have a data RAR environment, you need to do some steps manually. It's not fully automated yet. Some people ask us, what's the difference of AutpUpgrade patching capability and fleet patch and provisioning? The answer is AutpUpgrade patching capability is when you have a few databases and you simply download one 3 megabyte jar file from my Oracle support, which is free to use. You deploy it, then you clone this database home, you apply the new patches and you use it. So it's something quick and for small environments where you have a few databases. While fleet and patching provisioning is a corporate solution where you have dozens of databases that you want to apply the patch at the same time, or you need to be under some compliance standards where all your databases need to be at the same patch level. So fleet patch and provisioning is a solution where you will have the fleet patch and provisioning server, which works similar to Enterprise Manager. You have a different application, and then you will have agents under your database servers that will be connected with this server, and then you can perform actions from this server and control all your data center, okay? And also fleet patch and provision will automatically provision and download the patches for you, provision the new homes. So it has much more automation there, but it's a corporate solution. It's not a very small, simple tool like we have in AutpUpgrade for the patching capability. Now back to you, Roy.
Well, thanks, Rodrigo. I think now that we've looked at it from the higher level of our strategy and the large patch bundles that we have on a quarterly or monthly basis, maybe we should go down to the lowest level and look at what is actually inside a patch and how they get applied. So first of all, what is a patch? Well, a patch is a bunch of changes to your database, and those changes come to you as a set of files. Now, some of those files are binaries, for example, that might have to be placed in your Oracle home because they update the features and functionality that come with the Oracle executables. But also, as part of a patch, you get apply and rollback scripts. Those are the scripts that take the actions to actually apply the patch to your database. Or if you do need to remove the patch or roll it back, you have a script to do that as well. Now, the actions that take place in those scripts could be as simple as a single line of SQL, such as an alter or create, or maybe you're revoking privileges from a user or something like that. Or we might be replacing program units within the database that are written in PL SQL, or updating view definitions and those kind of things. So any individual patch could be any one or more of these things all in one single package. So how would you apply a patch? Well, opatch is the directory that you would look at under your Oracle home. And the opatch directory has a lot of files in it, but the two that you really want to know about are opatch and Datapatch. Now, what is the difference between these two? Because a lot of times people conflate the opatch part of patching with the Datapatch part, but they are separate and distinct operations, and they're actually separate and distinct programs, as you can see here. What opatch does is it lays down the new binaries in an Oracle home, not necessarily just an Oracle database home, by the way. Opatch can be used for applications. It can be used for middleware as well. When you're updating the binaries that are being used, that means that the application or the database has to be shut down on that node, on that instance of a RAC cluster, for example, or the entire database is down if it's a single instance. And that's because we have to replace the binaries and then start up using the new binaries. With Datapatch, however, we're applying SQL changes to the database. And of course, you can't do that if the database is down. So for Datapatch, the database must be up and available. Now, if you're wondering what's installed in your Oracle home, because you may have many patches, you may have the release update, which could be thousands of patches in one tested bundle. You may have multiple bundles. You may have multiple individual patches. Well, one thing you can do is run your opatch ls inventory, and that will give you all the details of every patch. If it's a merge patch or a bundle, all of the bugs fixed by it with a description, when it was applied, and so on. You could also use ls patches. Or from within the database, there's the PL/SQL package DBMS QO patch, which has a lot of functionality that lets you query the patch inventory. Basically, what it does is it uses external tables to access the patch inventory and the queryable inventory on disk to give you information from within, say, SQL Plus or PL/SQL itself. And if you want some simple queries to see then what is applied in your database, then we have a couple of views there. The DBA registry SQL patch or CDB registry SQL patch views will tell you what patches are applied to your database. And note that it is possible to have patches that have been applied to your Oracle home, but not yet applied to the database. And now, I can't remember when we implemented this, but now when you start up a database, you will get a message in your alert log if there are patches that have been installed in your Oracle home, but not yet applied to the database using Datapatch. That's a little helpful safeguard that we've built in. So that's just a little bit about what goes on at the lowest level of patching. And now I'll turn you over to Mike for some information about patching methods.
Thank you, Roy. Now let us hop to the next topic, patching methods. And a colleague of ours recently made a quote and said, look, patching, generally database patching, but also patching, especially in a RAC cluster, is like crossing this very, very busy street. Would you cross it like step 1, step 2, and so on? Or would you rather try to make sure everything is in shape and then you cross as quickly as possible? I know, or I guess we all know the answer, what you would prefer there. And let me give you an idea why thinking about that for a second is very important and then taking the right decisions. So which patching methods do we offer? In-place patching is the first one. So I have a 1918 home here in my case, and in place means I stop my database. Then as next step, I will apply the most recent release update 1919 to it with opatch apply. And once it's a 1919 home, I can start up my database. And once the database is started, I run datapatch minus verbose. Now, what is the upside? That looks very simple. You don't need a lot of extra space, except for the previous information will be stored in the patch storage subdirectory, but opatch now offers a way to clean up. The real downside of that is, if something goes really wild, you destroy your home. So you basically sit there with a database, you can't start it up anymore. Or if you decide after a short while you would like to go backwards, that means you have to stop your database again, remove everything, make sure it's 1918 afterwards, so roll back the patch, especially when you have one-off patches, this can become really, really an interesting way of going backwards. And then you need to bring up your database again and run datapatch minus verbose, and datapatch verbose does the right thing, but the downtime is really high. Try to avoid that. Better, much better, to out-of-place patching. Out-of-place patching means I start again with 1918, then I clone, or actually I prefer to have an absolutely fresh home, install into that fresh home my most recent release update, which in my example here with opatch apply will be a 1919 environment. And once this is there, I simply shut down my database, relocate my services and my environment, and start up in the new 1919 environment. And once the database is up and all PDBs are up, I run Datapatch verbose and it does everything for me. And if I need to go back, no problem. I reversed it. I stop my database, I bring it back in the old environment, run Datapatch verbose, it does the right thing. So the downtime is very little, and I have no risk of sitting there with no Oracle home in the unlikely event of something really going the wrong way. So try to do out-of-place patching. Why do we emphasize on this several times throughout this seminar? Our friend Tim Hall, and I think you all know Tim Hall from oraclebase.com. Tim made a poll on Twitter not that long ago. And Tim asked, where do you patch? How do you patch? Which method do you prefer, in place, out of place? And a lot of people answered that. And I knew the result already beforehand without looking at it because we talked to a lot of people. But the majority still prefers to patch in place. We would like to change that. So from tomorrow on, you please don't click on in place anymore. You tell us, and not only click there, but you tell us, now I patch out of place. It's way more safer, it's way less downtime, and you mitigate the risk of sitting there without a home. So always, always please patch out of place. That's the way to go. And if you want to safely test and verify patches, and you have a physical standby database, then you can use the standby first apply. And release updates per se are always standby first patchable. So how does this work? I have my primary, I have my standby on the right side. They are both 1918 homes. So what do? Again, I start with, in my case, a fresh home, and I apply to that fresh home with opatch apply the most recent release update, which in our example will be 1919 here. Once my home is 1919, it's very simple. I stop my standby and I relocate the service, and it works with and without RAC, and I start it in managed recovery mode in the 1919 environment. Now I have the first assertion. I see if the redo apply runs successfully, if all goes fine. But this is just half of the cake. How about Datapatch? If I want to test Datapatch, whether it's running fine, giving me strange errors, or doing something very unexpected, I will convert my standby now into a snapshot standby. And please, no fear about snapshot standbys. It's such a bulletproof technology. It writes in the background a guaranteed restore point, and the redo shipping goes on. So in case of the very, very Murphy-driven event of you lose your production right now, you have to fail over in that situation to the standby. The only downside is that the failover may take a little bit longer because you may have received several gigabytes of redo, and the redo needs to be recovered before we can make the standby now available as a new production. But it's really a very safe way. And since a snapshot standby is a read-write standby, I can easily now run Datapatch verbose on it. And once I'm good, I can go back into the redo transport. I convert my snapshot standby back to a physical standby. And then the redo will be consumed, which has been accumulated over the time I tested here. And all is good. So you don't lose the capability of disaster recovery or whatever. It's all good, all safe here. But if I want to use the standby now really for the patching, you see the standby is now 1919, but it has no Datapatch knowledge. What do? I exchange the roles. So I switch over to prod 2, which is my standby here. Then I stop my new standby, which was my production before, and started in a 1919 home as well, and enable redo transport. And then I run Datapatch verbose now on the live instance because it's live. You can run it there. And so I had one switch over and all is good. So this would be a very safe, very productive way of using your standby environments for, first of all, the testing of patches, but second also for the patching itself. You don't save downtime with that. If you have a single instance, you need to bring it down if you do it on production, or if you do it with the standby. There's no difference there. So you have that downtime here for the switchover or for stopping production in one home, bringing it up in another home. A patch, as I said before, must be marked as standby first installable. So please always check the README, and release updates generally are always standby first installable. Execute Datapatch then, of course, on the primary database, whatever your primary is. So in my standby case, the primary is now the previous standby, and there you will execute Datapatch. There may be a few restrictions. Please follow the guideline in this My Oracle support note. But how do we avoid no downtime? I want no downtime at all for a release update, and there's only one way to do that. You avoid downtime with RAC Rolling patching. So how does this look like? We have the application, the users, and they're connected to the instances on each of the nodes in our cluster. Now, in each of the cluster nodes, we have an Oracle home, and of course, on the bottom of the slide, we have the database. So the idea is this database should be kept up and running all the time. So what do? Again, same thing. And here we can use opatch auto, which is sort of a orchestrated opatch way. I clone my Oracle home. I provide a new Oracle home, whatever I prefer. And then I run opatch auto. So it patches now node by node. The instances get patched. But the database still remains up and running while that happens. No interruption. The interruption will come now node by node. So a node will be drained. That means the user connect via the scan listener to the next instance and so on. So it goes round robin through all the nodes and drains and then reconnects the connections on the next node. So it moves home by home by home. And once this is done, opatch at the end, and we had a change coming for that 2 years ago, I think, opatch now executes Datapatch only on the last node and doesn't attempt to patch with Datapatch on every node after changing to the new home. So this is a good way. The database stays up and running all the time. And there are a few things which we should talk about. A few best practices. So if you have a problem draining the node, draining your application, then patch node by node or patch in groups. Like if you have a 4-node cluster, build 2 groups of 2 each, and then patch in groups. Patch the standby cluster first would also be a good idea. So in this case, we call it a premium protection, actually. You know when you use it on a standby, all is good, it works fine, and it allows you the full testing on the standby cluster for functionality and also for the rollback. So you combine really the 2 best pieces. You have a production RAC cluster, you have a standby RAC cluster. That's ideal. Then please execute Datapatch immediately after the last node has been patched. This applies when you don't use opatch auto, when you do it by yourself. When you do it manually, then make sure you don't delay it. And execute has to be repeated. Execute Datapatch on one node only, not on every node, please. And now something which is really, really important and sometimes also leads to misunderstanding. Because in the old releases, we told you the grid infrastructure has to be always the highest version in the entire cluster. Now with the new release numbering scheme since 18C, the question came up so many times, can I combine like 1914 grid infrastructure and 1916 database home? Yes, you can. The MOS node is pretty clear on that. The patch level can be different. It can be, but ideally you keep all in sync because this is what we test. When we release 1919, we don't go in and now try 1919 grid infrastructure with 1914 database and 1915 and 1916 and so on. We test 1919 GI with 1919 database. And this is what we highly recommend to you, even though we know that some of you patch the database home more often than the GI home. So sometimes the GI home hangs a bit back. But in an ideal scenario, you please keep them in sync. So you can have these combinations like 1914 GI, 1916 database, or the other way around, 1918 GI, 1914 database. You could also have grid infrastructure 1914 on node number 1 and GI home 1917 on node number 2. And the same for the database. But please don't do that. I will tell you in a minute why you should not do this. You could also say, let me patch node 1 on Monday, node 2 on Tuesday, node 3 on Wednesday, and node 4 on Thursday and Friday. Happily, we are ready for the weekend. Don't do this, please. I come to this point as well. You can operate a cluster with different Oracle versions of either GI or database on each node. It's technically possible, but you should not do that. And the question is, can I delay patching or omit patching to a subset of instances or nodes? So can I do that? What I showed you on the slide before. Can I have on node 1, 1914 and node 2, 1917? And even though it's technically possible, we say don't have that. All patching operations should be completed on a real application cluster environment as quickly as possible. You should not delay that. You should not have these mixed combinations. When applying patches to a GI environment or a database home, these patches must be made effective as soon as possible. And don't run it longer than for 24 hours in a mixed environment. And I don't feel very well if you tell me we are doing this for exactly 24 hours. Go node by node, straightforward, like crossing the street. You don't go just 5 meters into the street and then you wait for a car hitting you. That is very unlikely. And don't do this with your cluster. Rolling patching of RAC clusters with the draining of connections is a recommended and well-tested process. This is what we do when we operate RAC clusters, and we operate a lot of those. You can run with mixed patch levels, but be aware, this brings risk, and we never test this. It's less robust. Don't try it. And running with a mix of patches across a cluster for an extended time, which, for instance, would be multiple hours or a day or longer, this really exposes the entire situation to unexpected corner cases, something we had not tested. It may also have an effect on scalability, on even the availability. So, and in worst case, some functionality maybe not working as expected or being restricted in that situation. So don't do this. When you patch with a delay, some cluster features may operate with limitations. And also some ASM operations may be limited or simply not even there. So we strongly, and this is why it's marked in red here, we strongly recommend that you patch as quickly as possible. In a future version of GI, we may lift one or the other restrictions we have these days, but please patch as quickly as possible. And as I said before, release updates are always standby first and always RAC rolling. So that is true, and this is why you definitely should patch as quickly as possible. Be on the safe side, put up your umbrella. If you have a standby, leverage the standby, but patch your RAC environment as quickly as possible, straightforward. Use our draining abilities. And this is how you should move forward. Now, if you look for the gory details of GI and database patching, I'll hand over to Daniel. And Daniel will explain you in all detail how we approach it.
Thanks, Mike. Interesting facts on RAC databases. So now it's a good time to talk about patching grid infrastructure. I'm going to show you a few patching concepts that you can use when you patch GI, but you should know that you can use the same patching concepts when you need to patch the Oracle database as well. The first method that I would like to talk about is the simplest one. It's called all-node patching. When you use that method to patch your cluster, then all the instances are brought down at the same time. You can then patch the instances and bring them back online. Because you bring down all the instances at the same time, it means that you have a database outage. And the outage lasts as long as it takes to patch all the instances. You can use this method for all kinds of patches, even those patches that are non-rolling. Another method is what we call minimum downtime. In this concept, you divide all the nodes in your cluster in two groups. Then first you take down the first group and apply patches to those instances. Then you take down the second group. So now all your instances are down, you have a database outage. But at the same time, you restart the first group of instances. So as soon as those instances in the first group is up, then you can connect to the database as well. But in this method, there is an outage while we stop one GI stack and restart the next one. Next method is rolling patches. When you do that, each instance is taken down for maintenance to apply a patch, and then it's brought back online. Then we take the next instance, until all the instances has been patched in a rolling manner. Because all the time there's an instance available, it means that the database is online and available for the entire duration. There is no database outage. Like with the previous method, when you take down instances for maintenance, the other instances in your cluster must be able to handle the workload. So again, a cluster that is running at almost peak capacity, it can really hurt if you take out instances. A variation of rolling is rolling in groups. Instead of taking each node individually down for maintenance, you divide your nodes into groups, and then you take out one group and do a rolling patches, and then you proceed to the second group and do rolling patches. This method is useful if draining is a problem to you. But again, here you're taking out a group of instances from your cluster, so the other group must be able to handle that workload. Rolling installation of patches is really preferable. It is the best way of applying patches to your cluster because you don't take down the database. You can patch your infrastructure, but the database remains online. You can hide the outage from your users. Rolling patches is really cool. But in order to do it effectively, you must be able to drain your instances fairly quickly. If you have problems draining, then consider rolling in groups instead of a traditional rolling patch installation. I strongly recommend that you complete a rolling patch installation as soon as possible. When you start to work on the first instance, you should finish your work. You should finish patching the entire cluster as soon as possible. Ideally, you need to process all instances in your cluster within 24 hours. As soon as you start a rolling patch apply, it is marked in the cluster that it is in a rolling patch state. In rolling patch state, some of the really cool functionality in the cluster is disabled. Being in rolling patch state is still a supported state. The database will work. Your users can connect, no problems there. But we do disable some of the cool functionality in the cluster. So finish as soon as possible. We also need to touch a little upon draining. Draining is important when you need to patch grid infrastructure or when you need to patch a cluster. Imagine that the first instance in our cluster is going down for maintenance. You can then stop or relocate the services that are running on that instance. And when you do that, a fan event is sent out to the users that are connected to that instance. They are told that this instance is going down, finish your work, and then move to another instance. Idle connections or connections sitting there in the connection pool will immediately disconnect and reconnect to one of the other instances in the cluster. But an active user with a long-running transaction will have time to finish their work and then eventually, at a proper point in time, release that connection and reconnect again to one of the other instances. In this period, the scan listener knows that one instance is going down, so it'll assure that new connections is sent to one of the other instances in the cluster. When you create a service, either using SRVCTL or DBMS service, you can set a default drain timeout. So whenever something needs to happen with a service on one instance, then this default drain timeout is applied. I can set it to, for instance, 10 minutes. So when I stop a service, then the users will have, by default, 10 minutes to finish their work and move to another instance. Of course, if I need to do emergency maintenance, I can then override that default timeout if the situation warrants that. When you set drain timeout, either as a default drain timeout on the service or when you stop a service or relocate a service and you specify a drain timeout, don't set it too low. Don't set it to 5 or 10 seconds. Even though I told you to complete a rolling patch installation as soon as possible, by setting it too low, if you have an instance with hundreds or thousands of connections and they leave within a very short time period and connect to another instance, that can lead to a login storm. Set a higher drain timeout so the transition can happen more smoothly. But on the other end, don't set drain timeout too high, because if you do that and you have many nodes in your cluster, you will have your cluster in rolling patch state for an extended period of time. You really want to complete the rolling patch installation as soon as possible. Also, when you are in a rolling patch state, the cluster is not operating at full capacity because you have instances down for maintenance. So finish as soon as possible and don't set drain timeout too high. Generally, you should ensure that the application that connects to your cluster complies with the maximum availability architecture. When you go and look in the technical brief, it has some very detailed information on how you can configure your application. It has advice on how to create connection strings, creating and maintaining your services, and so forth. This is really the place to go when you need to configure your application in such a way that it works smoothly with cluster databases. If you're using DataGuard together with your cluster, there's an alternative approach that you can use when you need to patch your entire environment. This is a typical DataGuard setup. We have two clusters that are connected in a DataGuard environment, one primary and one standby. When we need to patch this entire environment, we can start by patching the standby site. You can take down all the instances on your standby site and do all node patching there. It might be the easiest things to do. But of course, if you have read-only traffic on your standby database, if you use active DataGuard, then you can patch your standby database in a rolling manner as well. Now that we have patched the standby site, we can then do a regular DataGuard switchover. So now the users will be interrupted. They'll be told on the primary database, hey, finish your work as soon as possible and move to the standby database. Then the users can now connect to the standby site, which is now the primary database, and they can continue their work there. Now we can proceed on the former primary site. We can then patch that. And now our entire DataGuard environment, both clusters have been patched. And the only interruption that our users saw was a DataGuard switchover. This is really useful if draining is a problem to you. And of course, it has the added benefit of testing your DataGuard configuration. Can you really rely on your switchover or failover if you need it? This is a good method of testing it. If you want to know more about DataGuard in a cluster environment, you can visit our YouTube channel. We have an interview with Ludovico Caldera, the DataGuard product manager, and he shares some really interesting ideas for DataGuard running in a cluster environment, including things like what to do with fast start failover. When you have one instance down and you want to apply patches to create infrastructure, you can do it in two ways. Just like the database, we have in-place patching and we have out-of-place patching. When you do in-place patching, you use the opatch auto tool. But in contrast to that, we also have out-of-place patching. Again, here you can use the opatch auto tool. It has a dedicated command line parameter for out-of-place patching. But you can also deploy a brand new home with grid setup and then simply just switch the GI stack to that as well. So there are more ways of applying patches when you do out-of-place patching. Like with the database, we strongly recommend that you use out-of-place patching. When you use out-of-place patching, it minimizes the downtime you need to apply patches to the GI. It also minimizes the risk because there's less things to do in your maintenance window. And in case you need to roll back to the previous patch level, that is also a lot easier when you use out-of-place patching. Now, it's not only about patching grid infrastructure, it's also about patching the database. There are two options here. Either you can patch GI and the database together, or you can do it separately. If you do it together, you only need to take one outage. You have one maintenance window, but it needs to be so long that you can patch first GI and the database. In contrast to that, if you patch GI and database separately, you need to arrange for two maintenance windows, but they'll be shorter because there's only one operation in each of them. If you decide to patch GI and database separately, the two maintenance windows that you arrange for GI and the database, they should be fairly close to each other, like 2 following weekends. Don't patch GI in 1 month and then proceed with the database 3 months later. Keep it fairly tight. Here's a few tips for patching grid infrastructure. The first is about the cluster verification utility, or CLUFI. Before you patch GI and after you patch GI, you can use the cluster verification utility to ensure that there is no problems with your cluster. Ideally, you use CLUFI, or the cluster verification utility, through either AuraCheck or ExaCheck. So go to the appropriate channels and get the latest version of AuraCheck or ExaCheck, and then run these checks before and after you patch GI. It's a lightweight and non-intrusive check that you can run while there are users connected to your cluster. The second tip is about patch level. Like with the database, you should patch grid infrastructure regularly. You should apply release updates and put MRPs on top. Also, I recommend that you keep the GI and database patch level in sync. So if you patch GI to 1919, you also patch your database to 1919. We do recommend mixed version or mixed patch levels, but in our own house, inside Oracle, our autonomous database, all our cloud services, all our software as a service, when they run on cluster databases, this is the method that we use, and this is what we do the majority of our testing on. So I strongly recommend that you keep the database and GI patch level in sync. Also, implement application continuity. It is a really good way of hiding both planned and unplanned events from your end users. Again, here I'll refer to the maximum availability architecture. They have really good examples on how to implement either application continuity or transparent application continuity. The final advice is about opatch. You should always use the latest version of opatch, like with the database. And I recommend that you use the same version of opatch in your GI and in your database home. Now, I love patching. Patching is like my fourth baby. But I also recognize that patching is a lot of work. Ideally, you patch every quarter, but at least you patch fairly regularly. So it really puts a lot of work on you. If you have only one cluster to manage, well, then it's probably doable. But if you have 5 or 10 or hundreds of thousands of clusters to manage, all this patching can really become a lot of work. In that case, you really need to look into Oracle Fleet Patching and Provisioning. FPP can fully automate not only patching grid infrastructure, but also the database and your Exadata. And it is aware of whether you use data guard and so forth. Simply by a few commands, you can patch your entire stack. FPP is really such a cool tool. So if you have a big estate, you really need to look into FPP. Now it's time for Java. And I don't mean a coffee break. We need to talk about Java in the database, and Mike, our Java expert, will guide you.
Thank you, Daniel. Now let us cover the quarterly patching. So the idea, it starts actually with finding and deciding whether you need the right patches, whether you have them, one-off patches, whatever, in your environments. And don't tell us your database is not facing the internet. We all know that is not true. Of course, your database server is usually not connected directly to the internet, but of course, there are enough people in your company using email, and we all know that more than 90% of malware gets spread via email attachments or somebody clicking somewhere. That happens, and then your database server is easily attackable as well. So every quarter, we release the so-called critical patch updates, which means you have to check, you can check. We deliver enough information with the critical patch updates, giving you an idea whether you need and should apply the bundle patches. Every quarter means in January, April, July, and October, always at the Tuesday closest to the middle of the month, we release the patch bundles, the quarterly patch bundles. Now your question is, do you need to apply them really? Or can you skip them? This month, I'm not in the mood. Should we skip them? So how do you evaluate the risk? And with all the products, we deliver a so-called risk matrix. Intentionally here, we use the July 2022 one. And we would like to show you a few things which are really important. So at first, on the left side, you see which product is affected or which part of the product. So when it says like Oracle Enterprise Edition, that means the core database is affected, while the next topic, the second one is sharding, third one is Recovery Manager, fourth one is OJVM, the Java Virtual Machine, and the fifth one is Oracle Apex. So you can decide or make a first distinction whether this issue really may hit you or not. If you don't use sharding, the second one may not affect you. Now, in the middle of the slide, you see the base score. 9.1 means that's close to the high score of 10. This is critical. It's the Database Enterprise Edition. It affects basically everybody. And when you look now on the right side of the slide, you see that Oracle versions 12.102, 19c, and 21c are affected. You could think now, my 11.204 is not affected. That's all good, or my 12.201. But look at the headline. It says supported versions affected. That means in this column, we only specify versions which are under bug fixing support. 11.204, 12.201, 18c were not on a bug fixing support anymore when this risk matrix got released. And when you look at a newer one, you will only find 19c and 21c in there. But this doesn't mean this issue doesn't happen with 11.204 or 10.205. So be really aware, only the supported versions are mentioned. If there's not exclusively only one version here, that means basically in most cases, all the previous ones are affected as well. A very important part here, and this is often leading to discussions, is the Oracle Java Virtual Machine, the OJVM. And be aware, if you have Java applications, and many of you have Java applications in use, that doesn't mean that you use the Oracle OJVM. The OJVM is a virtual machine inside the database where you have stored your Java sources in the database and compiled them there. Many Java applications connect with, for instance, JDBC, and they don't use the OJVM. So having a Java application doesn't mean you use OJVM. But we need to find out, do you have OJVM installed? Do you need it? And do you use it? Why is this so important? Because we went back until January 2015, and with every quarter, there's at least one OJVM issue mentioned in the quarterly patch bundles, and the average risk score is above 7. So 10 is the high score. That means in average, we are above 7, and you see some really high 9 and 8 things here. Basically, if you have OJVM, you should patch quarterly. How do you check if OJVM is installed in your database? You simply check DBA registry or CDB registry, and if you find Java VM, that means your OJVM or your database has OJVM installed, which is the standard, by the way. What do you do now? Option number 1 is you patch quarterly. The OJVM bundle patch is a separate download in 19C, and from 21C onwards, it's part of the standard database RU, which of course will apply to 23C as well. That is good. No separate download anymore. In a single instance environment, you need to take the database down anyway. But in a RAC environment, you can patch rolling and the database stays up all the time. Of course, each instance must go down, as we explained before, in a rolling fashion. That's okay. But this MOS node here, all mentioned on the slide, is extremely important. Because at the beginning of this chapter, I ask you, is OJVM used? And this MOS node, even though it describes the rolling approach for RAC environments, it has all the queries in it to check whether somebody is really using OJVM or not. So you can find out with this MOS node, do we have sources? Do we use OJVM? And this may be a decision maker of what the best option is for you. Still, option number one means we patch on a quarterly basis, because we know from experience and the risk matrix, usually there's an OJVM thing here, and so we need to patch. With 21 and 23C, the RAC in RAC environments, the patch is fully rolling installable. And when we run the Datapatch, there's no interruption. Because in 19C, same behavior, binary is rolling, but when you run Datapatch, there's a brownout of 10 seconds to restart the Java subsystem for all instances in a cluster environment. In a single instance environment, you don't care about that. But in a cluster environment, you care if you have an application using OJVM. So if the node on the previous page told you, oh, we don't have an application, then you don't even care because it will be fully rolling and you don't care about the 10-second brownout for the Java subsystem. But if you have an application, then your application may get this ORA 29548 error when the Java subsystem gets restarted on all nodes. Second option, you disable OJVM with the mitigation patch. Now, the good thing is the mitigation patch is on all your homes since 2018. Nothing to install, it's usually always there. And the mitigation patch allows you to disable the Java subsystem. Now, when the Java subsystem is disabled, nobody can abuse your OJVM in the database, which is really a good workaround, I would say, if you can't patch quarterly. Still, we would recommend you patch quarterly, but if you can't, the mitigation patch is a good workaround. It has only one tiny flaw. The flaw is basically, before you apply the next patch, you must disable a mitigation patch, which then enables the Java subsystem. Then you patch, and once you're done with patching, you must not forget to enable the mitigation patch again, which disables the Java subsystem. You can use it also on a PDB by PDB level. That's possible. How does it work? You enable the patch generally, the functionality with the dbms jdef.sql. Once you run that, you have now two calls in the database. The first one, you see it on the slide, allows you to disable the OJVM, so you disable the Java subsystem. The second call re-enables it, which you have to do before you patch or upgrade. And then afterwards, you must not forget to disable it again. In a multi-tenant environment, it would be a good way to disable it generally in the PDB $seed, which means when you provision a new PDB, it's disabled by default. And then you can enable it at will if somebody really needs the OJVM in that specific PDB. Third option, and this is a very strict option, you remove it. You deinstall OJVM. Be aware of two things. First of all, there are dependencies. That means with deinstalling OJVM, you may need to deinstall other options as well in the database or other components. Second thing is, especially in a multi-tenant environment, be very cautious and test thoroughly before you do it in production. If you find any issues in your testing, open a service request with Oracle support and check with support. We found out that especially with RUs in 19C, from each to the next RU, there may be a change in the removal procedure, what you need to clean up. Because the removal procedure is not always working as perfectly as you would expect. In non-CDBs, usually it works fine, but with CDBs, it's a bit more tricky. You find also a link to a blog post explaining how to remove OJVM, but the previous two Moz nodes mentioned here, they always target like the repair of the OJVM, which means you basically stop after removing it and you don't reinstall it again afterwards. So it's a documented approach, but test it thoroughly, please. Then there's no startup upgrade required. This is a myth, and we just found this in a Windows README of actual current days where it was just forgotten to remove that. So startup upgrade is not required when you run Datapatch. Never, and not even for Java Virtual Machine. If you had used the patching process with startup upgrade before, then you may need to, when Datapatch errors out, then you may need to use this workaround with -skip upgrade check, because it had written a flag in the database for the startup upgrade, and with this -skip upgrade check, that flag then gets removed and you override that. This brings us then to the next topic, and I give back to Daniel here for patching insights.
Thanks. Now let's move on with some patching insights. Previously, we found the right patches to apply. Now let's see how we can get them onto our Oracle home. This is an overview of the process. First, we check for the newest version of opatch. We download the patch file, the zip file from my Oracle support. We check for conflicts. Then we shut down everything that runs in that Oracle home if we do in-place patching. And then we can apply the binary changes to the Oracle home using opatch or opatch auto. Like I told you previously with grid infrastructure, you should always use the latest version of opatch. When you check the patch README file, it might say that it's fine to use an older version of opatch, but put it into your runbook. Make it a rule for yourself that you always use the latest version of opatch. When you run opatch and when you put the patches into the Oracle home, if you think that it takes too long to apply those patches, try and switch to out-of-place patching using a brand new Oracle home. Don't use in-place patching, and don't use cloning of Oracle homes. Cloning Oracle homes is really convenient, but it has a downside. It's better to get a brand new Oracle home. So you go to oracle.com and you get the base release 19.3, and then you apply only the patches you need on top of that. The problem by reusing Oracle homes like you do when you clone is that over time you will see that the disk footprint of that Oracle home increases, and also the patching runtime increases. And the reason for that is that opatch has some really cool rollback functionalities. opatch allows you to roll off individual patches. You can go all the way back in time. You can go back all the way in the history of that Oracle home. So imagine that you have 1919 and you have applied every release update before that, 1918, 1917, 1916, and so forth, all the way back to 1904. You can roll back with opatch to any release update in the history. In order to have that cool functionality, it comes with a price. And the price is that opatch stores a lot of information inside the Oracle home. And that is why you see that the disk footprint increases. Now, the patching runtime also increases because opatch needs to keep track of all these patches that you over time have installed on that Oracle home. That information goes into an XML file that is processed multiple times when you use opatch. The more information you have in that XML file, the more patch history you have there, the more dependencies and so forth, the more complicated that check will become, and it affects the runtime of the opatch operations. In opatch 37, the opatch release that came out in April this year, there's a new functionality called opatch util delete inactive patches. So you can simply remove some of that old patching history. You can get rid of that from your Oracle home. This can alleviate some of the pain that you see when you're reusing Oracle homes. We did a small test to see the difference between an Oracle home on which we have installed all the release updates consecutively, compared with the base release and just the last 2 Oracle homes. So we've gotten rid of all the patching history. And as you can see from the bottom line, the patching runtime really changes from almost 20 minutes to slightly under 5 minutes, just by getting rid of some of the old patching history. Of course, the price that you need to pay is that you get rid of the patching history. But let's be honest, if you apply 1919 and need to roll off that patch, then you go back to 1918. You will never go back to 1914. So get rid of all that old patching history. Use the opatch functionality to clean up the Oracle home. So in order to install a patch, I recommend that you get the base release 19.3, go to oracle.com, download it, and then unzip it. Get the latest version of opatch, regardless of what it says in the README. Always get the latest version of opatch. And then you can attach the new Oracle home to the inventory on the server by using the run installer command. And at the same time, you can install the new patches, the release update, the MRP, the data pump bundle patch, and all the other patches that you have. You can install that while you attach the Oracle home by using the run installer command line parameters called apply RU and apply one-off. That's a very convenient method when you need to provision new Oracle homes. Now that we've fixed the Oracle home, it's time to look at the database, and I'll leave it to Rodrigo.
Thank you, Daniel. So Mike talked about how to find the right patch, and Daniel how to download and install it on the binary level. Now I will show you how we need to apply the patch on the database, meaning the dictionary layer, to align it with the binary level. So first, what we need to do is start the database in the new Oracle home where you have the patches applied. And remember, you need to start the database in normal mode and open all the PDBs. If you don't open all the PDBs, those PDBs that are not opened won't be patched. So they will be skipped. And then if you decide to open them later, they will have a PDB plugin violation saying that you need to run Datapatch on them. Okay. So again, you start the database in this new Oracle home, and also you open all the PDBs. And finally, you call the Datapatch utility that is inside Oracle home/opatch, and this utility will patch all your databases and PDBs. One important thing to remember is to always recompile invalid objects before you invoke Datapatch. The reason why is because then you will know if Datapatch caused any object to become invalid after you executed it. So you can know exactly the objects that became invalid because of Datapatch. Okay, so now let's see that in a patching timeline. Again, first you run utlrp. Then you shut down your database. Now, why you shut down the database? Because you're going to be moving this database to the new Oracle home where you have the patches applied. So you stop the database, you start it back in this new Oracle home. And don't forget the database must be opened, and also all the PDBs that you want to patch, they need to be opened. So ideally, open all the PDBs of this database. And another thing to have in mind is that you don't need to open the database in restricted or in upgrade mode. You can simply open it in normal mode. There are a lot of people that use those 2 modes in the past because they thought it was a requirement, but it's not a requirement. You can have your database opened in normal mode to perform the patching operation. So the only downtime you had during this process was during the shutdown and the startup of your database. At this point, after you start up and open all the PDBs, you can allow your application and users to connect on this environment. There is a very good blog post from Daniel from our team, and he shows how and why you can have users connect in the database while the Datapatch is running, and also the potential problems that you can face. So users start connecting your database, and now you call Datapatch. And again, during the data patch execution, you can have potential concurrency. So that's a side effect of having users connected while you're running the data patch operation. For example, let's say a user is using DBMS stats to gather statistics of a given table. And at the same time, Datapatch is trying to replace this package with the newer patched version of it. So in that case, we will have a concurrency, and what Datapatch will do is it will try to acquire a lock for 15 minutes. And if it cannot get that object after 15 minutes, then it will have a error and timeout, okay? You can optionally find the block sessions and kill it while Datapatch is waiting for those locks. And if you want to change this timeout period, you can use this _KGL time to wait for locks parameter. But we don't recommend you touching this parameter unless guided by an Oracle support engineer, okay? Datapatch uses registry $SQL patch to document everything that happened regarding patch apply in your dictionary, and also patch rollback. So every time Datapatch applies or roll back a given patch, it will add a new entry. So every time Datapatch is called, a new row is added on this table. That's like a history table of all the Datapatch actions in your database. Datapatch will automatically recompile only the objects that were invalidated during the patching operation. So let's say you had 10 invalid objects before you started Datapatch. Those 10 invalid objects won't be recompiled by Datapatch, okay? It will only recompile the objects that the process made invalid. And if more than 300 objects are invalidated, then no recompilation takes place. The reason why is because this can take a lot of time. So we recommend you to recompile it manually, or the objects will recompile on usage, meaning when you try to use that package that is invalid, the Oracle database, before allowing you to execute it, will try to recompile it. You can optionally adjust that threshold. You can use in the Datapatch command this -recomp threshold parameter and change this 300 default to another number. And always consider recompiling invalid objects after patching. So you remember our timeline? After the patching operation is done, run also a util RP after the Datapatch process, okay? A very good way for understanding what's going on regarding recompilation is opening this log folder, the SQL patch folder, and then you will have a subfolder with the SQL patch execution time. You open it and you do this grep using recomp threshold in all catconf files. And here you have, for example, those blue lines showing how many invalid objects you had before patching a given PDB and after patching, and also what was the recomp threshold that was used. So here we see that before patching, we had 0 invalid objects on the CDB $root, and after patching, zero invalid objects in the CDB $root. And the same for PDB $seed. Now let's talk about some advanced topics of Datapatch. First thing, how Datapatch works. Datapatch, if you go inside Oracle Home /opatch/Datapatch, you will see it's a very, very small file. It only has 2 or 3 lines of execution code, and actually it's a wrapper. We don't have anything inside. It's just calling another process. What does it mean? So when you get the latest version of opatch from my Oracle support and replace this opatch folder in your Oracle Home, you're actually not replacing the Datapatch process. You are just replacing the opatch, because the Datapatch is simply a wrapper to the real Datapatch. The real Datapatch is inside Oracle Home, SQL patch. That is the Datapatch process. And the Datapatch process is updated with the RUs. So Datapatch is not updated when you download the latest version of opatch from my Oracle support. Okay, and this SQL patch called the SQLpatch.pl that we also use the SQLpatch.pm, which is the Perl modules. Now regarding the apply sequence, a lot of people ask, imagine I'm going to a new Oracle home where I have some new OJVMs on it. I also have some new on-offs on it, and I'm also moving to a newer RU. How does Datapatch does this magic of building a patch crew, right? So let's see an example in the next slide. The answer is, first, Datapatch will always roll back any extra one-off that we have in the dictionary that's not present on the binary. Then it will handle the bundle delta, meaning if we are going to a higher RU or to a lower RU, it's going to handle that delta. And finally, it will apply any extra one-off that we have in the binary, but we don't have in the dictionary, okay? However, Java patches have a higher priority. So the Java rollback and apply process, they will always come first. So let's see this working in this example. In our binary registry, we have patch 4, which is a Java patch, patch 5, which is a bundle patch like a RU, and patch 6, which is a one-off patch. However, on the SQL registry, meaning on our dictionary, on the database layer, we have patch 1, which is a Java patch that we don't have on the binary. We have patch 2, which is a bundle patch, also a lower version compared with the bundle patch we have on the binary. And patch 3, which is an extra one-off that we don't have on the binary as well. So let's see how this patch crew is built. So imagine now we call Datapatch. The first thing we are going to do is the Java patches because they have a higher priority. So first we roll back patch 1 because we don't have it on the binary, but we have in the dictionary. And then we apply patch 4 because we do have this patch on the binary, but not on the dictionary. We do this to align the dictionary patches with the binary patches. The next step is to do the other patches because, as I said, Java patches have a higher priority. So first we are going to roll back the one-offs, and in this case, we roll back patch 3 because it's not present on the binary layer. Now we are going to resolve the bundle difference. So we are going to go from bundle 2 to bundle 5. Bundle 2 was what we had in the dictionary, and bundle 5 is what we have in the binaries. Here, we don't roll back one and apply the other. So for example, when you move from 1917 to 1919 RU, we don't roll back 1917 to then apply 1919. We only apply the delta scripts. So that's what I mean by resolving the bundle delta, okay? And finally, we apply the extra runoff. In this case, is patch 6. So that's how the patch crew is built. Finally, talking about the rollback scripts. So always when you call SQL patch and it changes your dictionary, it will create some rollback and apply SQL files, which are stored inside this Oracle home / SQL patch folder. You have one subfolder for each patch number. After those patches are generated, Datapatch will zip those files and put it inside the database table registry $SQL patch in the patch directory column, which is a blob column. So this blob column will have the zip file of all the SQL rollback and apply scripts that you had in your Oracle home. And why do we keep a copy of these objects inside the database? Because imagine you decide to unplug this PDB from 1918 and plug it in a lower release, for example, in 1915 or 1914. We don't recommend that, but we do support that. And how and why we support that is because we have this patch inside the database. So when the 1915 database check your dictionary, it will know that it is in a higher release that this version doesn't understand. However, when you call Datapatch process in that lower release will get the zip file, put inside the Oracle home, and run all the rollback scripts to bring this database to this lower 19.15 release. So that's how this magic happens, because we also have inside the database the necessary files to be rolling back a given patch. Now is with you, Mike.
So thank you, Rodrigo. And let us cover the final topic for today, the patching then in the multi-tenant environment. So standard is that $root gets patched first, and then $seed and the PDBs get patched in parallel. The parallel degree is determined by an internal algorithm based on CPU count mostly, and it then decides how many PDBs get patched in parallel. But even in the RAC environment, this all happens on a single node. So we can significantly speed up patching when you use AutoUpgrade in multi-tenant environments, because AutoUpgrade is able not only to automate your patching, but also to spread out the PDBs to multiple nodes. So distributed patching is the feature called, and normally you would see this picture here. So $root, $seed, and all PDBs get patched on node number 1. But with the distributed patching feature, we have now the PDBs distributed and then patched on different nodes in the RAC environment. How do you do that? That is very simple. When you use AutoUpgrade for patching, so here from 18 to 19, as you see from the homes, use this extra parameter, tune_setting equals distributed upgrade equals true. It will, of course, work also for database upgrades of PDBs and just distribute them to the available nodes. But here we speak about patching, and this is going from 1918 to 1919. We saw, not only for upgrades, but also in patches, around 40% improvement on 2-node RAC environments. And we know that many of you have 2-node RAC environments, so this is really a good way of leveraging the available nodes in multi-tenant environments. By default, AutoUpgrade uses 2 nodes. So how do you convince AutoUpgrade to use more than 2 nodes in case, let's say, you have a 4-node cluster? That is very, very simple. Just with the tune setting distributed upgrade equals true, you add separated by a comma, active nodes limit equals a number. So you override the 2-node limit with the desired value, and of course you should have the nodes available. Final thing in this seminar we would like to talk about is a general recommendation, a general best practice. You not only see faster upgrades with less components, you see also faster patching when you have less components. And typical candidates which may take a little bit longer are JavaVM, then still the multimedia part, even though it's really not fully existent anymore, but there are dependencies, and spatial data option. Just be aware, when you would like to take out some of the components of the database, there's sort of a dependency order. When we tested, we found out that you easily can remove the workspace manager and text and so on. But there's a dependency of ORDIM and SDO on JavaVM. The components with the highest impact in terms of when they are not present, speeding up patching, if this is really relevant, is of course JavaVM, but could be also the spatial data option. And don't get us wrong here. This is not a recommendation to remove all these options. But in a situation where I say, look, I don't use these features, these components in the database, but I have so many PDBs and patching time really matters for me, then you may think of, once going forward, maybe migrating or upgrading to a new release, of just removing the components you're not using. As usual, you find something on the upgrade blog about that. And with this, I would like to close and hand over to Roy for the final words on this seminar. Thank you.
Wow. Well, thanks, Mike. That's a lot of information over the last couple of hours. But hopefully all of these tips that you've heard, and I'm not even going to try to recap them in audio here, but everything you've heard here will help you take steps all the way to helping achieve peak performance for your system. With that, this is the close of episode 16 of our virtual classroom series. We've got the whole raft of other episodes that you can reference anytime you want for free on demand. MikeDietrichDE.com/videos. That's the Upgrade blog. If you want your videos in maybe a smaller format or a shorter length, you can pick and choose different topics from our YouTube channel, Oracle Database Upgrades and Migrations. And of course, it's helpful if you subscribe there, because then you can get more notification about things that are new and so on. So I'd like to thank you for attending. As always, we appreciate the attention, the input from all of our customers, and of course, we appreciate you for being customers. I'd like to point you to Mike, Daniel, and Rodrigo's blogs. They have frequently updated information that goes into great depth on specific topics, even more depth than we can go into in a 2-hour webinar. We have our previous webinar link here, our YouTube channel link, and I should mention that if you thought this was everything about patching, well, you're sadly mistaken, because our next webinar will be about from SR to patch. If you've ever wondered, why does it take so long to get a patch? This will answer the question and then some. So we hope to see you in June at that webinar. So I'll just close by saying thank you on behalf of Mike, Daniel, and Rodrigo, and the rest of us in the database upgrade, patching, and utilities development team. Have a great day.